Let's do a couple problems where we review our Pythagorean identity. Now, I've already copied the Pythagorean identity right here for you. Little side note, please remember that sine of theta squared is the exact same thing as sine squared of theta. Those are completely identical. You can use them interchangeably. Now, when we did Pythagorean identity last lesson, we plugged in one of these and then used that to solve for the other. So if we look at what we have here, I know that cosecant of theta equals negative root 5. However, cosecant of theta is not in my Pythagorean identity, so I'm just going to change this to sine of theta instead. And to change between those, I flip my point. Ta-da! Now I have sine of theta. So now I can come over here to my Pythagorean identity and plug sine of theta in and solve for cosine. So what I would like you to do is pause the video, solve this from here, then don't forget to remember to check that this is a quadrant 4 angle. So you should get a plus or minus when you end up square rooting. Pick which one you need based on this being a quadrant 4 angle. So try that out on your own and then come back to check your work. Let's check what you got. I solved this through. I got cosine of theta equals plus or minus square root of 4/5. That is the same thing as 2 over square root of 5 or 2 square roots of 5 over 5. If you got any of those are all identical. Now, we know that this is a quadrant 4 angle right here. And we have, oops, I messed this up. All students, there we go. All students take calculus. The C means that in this quadrant, cosine is positive, the rest of them are negative. So because we're in quadrant 4, that means we want the cosine to be positive. And we're done. Let's try F. This one is, once again, a little bit more complicated than the ones we did last lesson. This is still a Pythagorean identity problem, except this time we are given tangent of theta equals 3. But that's not helpful. I don't have tangent of theta in my Pythagorean identity. So instead I'm going to use the quotient identity, change tangent to sine of theta over cosine of theta, and then I'm going to times by cosine of theta to get it out of the denominator. And I get sine of theta equals 3 cosine of theta. Now, I could take this answer and plug it in for sine, because that's what sine equals. And I'd get this. And I could then solve that for cosine. However, notice in the problem, I'm not being asked to solve for cosine. I'm being asked for sine. So instead of plugging that in, let's come back over here and divide both sides by 3 to get cosine of theta is 1/3 sine of theta. And now I'm going to plug that in for cosine and leave this one alone. Now notice I only have sines in my problem, so that means I can now solve for sine. So first thing I'm going to do is this 1/3 sine of theta squared is 1/3 sine of theta times itself. So I have 1/3 sine of theta times 1/3 sine of theta, which is going to give me 1/9, because of the 1/3 times the 1/3. And then sine of theta times sine of theta is sine of theta squared. Now, if this trips you up a little bit, instead of all these signs, think of this as x squared plus 1/9 x squared equals 1. If I write it like this, I can see that these are like terms that I can combine. X squared plus 1/9 x squared is 10/9 x squared. So I can add these together to 10/9 sine of theta squared. I just changed those into x's so we can visualize it a little better. Now I can either divide by 10/9 or multiply by 9/10 to get sine of theta squared equals 9/10. Square root both sides to get sine of theta equals plus or minus square root of 9/10, which is the same thing as 3 square root of 10, 3 over square root of 10, or 3 square roots of 10 over 10. Now, once again, I still have that pesky plus or minus, so I come over here. My angle is between pi and 3 pi halves, so I think all students take calculus. If it's between pi and 3 pi halves, that's going to be my third quadrant. So in my third quadrant, tangent is positive, and all the rest of them are negative. So that means sine of theta will be negative. And we're done. So that is a little bit of an extension of the Pythagorean identity, some more complicated problems with that. In the next video, we're going to use the unit circle to solve for angles instead of